Okay, hello and welcome back to the Theoretical Revolution. My name is Mark Hatfull. You're now watching video 3. I just want to thank everyone if you've made it this far. I appreciate that you're interested. I appreciate your time, and I thank you for watching them so far. I'm sure you all have a lot of questions which I'll be happy to answer, but first we can just continue to watch all the videos, and hopefully I'll try and answer most of them in the tutorials. So, in my previous videos I discussed a basic concept, the balance of two forces, the inwards force of gravity and the outwards force of a pressure gradient or a vacuum. I then used this concept to explain the ring model. This ring model is the shape and movement of the universe over time. And if you've not seen these first two videos, then please watch them in order. You need to see video 1 and 2 before you start watching this one, because otherwise it won't make any sense to you whatsoever. Okay, so in the previous video I described the universe as a giant expanding mass. This mass is expanding due to the surrounding negative pressure of a vacuum, which I have called negative space. So here we have a giant mass. This mass contains all the mass of the universe, and outside of this mass is a true vacuum, a vacuum of negative pressure, which I've called negative space. This is different to the vacuum inside our universe, or this is different to space inside our universe, because it has an immense negative pressure. And in this talk I'm going to be talking about the space inside our universe, why it doesn't have a negative pressure, and why it is different from the negative space or vacuum outside of our universe. Alright, so what's wrong? Well, according to my theory so far, space is wrong, because if the universe is a giant expanding mass, then where did space come from? Space is a negative space. Space has no negative pressure. So, what is space, and why doesn't space have a negative pressure? And if the space inside our universe doesn't have a negative pressure, why would the space outside our universe have a negative pressure? Well, to answer that, I need to go into a bit more detail as to what exactly space is and exactly how space works. So, why would a vacuum outside our universe have a negative pressure if the space inside our universe has no negative pressure? Wouldn't there just be empty space inside and outside our universe? Oh well, before I explain any of this, we must first better understand what space is. So what is space and how does it work? Well, if we go back to the start, we know that our universe contains mass. We know that our universe is expanding. We believe that space is a vacuum. So, if we assume that space is a vacuum, then where did it come from? If the universe is a mass and the space is a vacuum, then the universe must be expanding into space, right? So, here's a scenario where the mass of the universe is projected into space. Here we have our universe, here we have the mass of our universe, and surrounding the universe is empty space. So as the universe expands, the mass of the universe expands outwards into the universe, or into the surrounding space. So here we have the mass of the universe, and it is projected through space. Alright, so it's scenario 1, the mass of the universe is projected into space, so the space fills the area between the particles as the particles are shot out into empty space. So if that's the case, then the Earth and all the mass in the universe would be shooting through space at a set velocity in a set direction. Yet if we look at our Earth, or our solar system, or our galaxy, we don't appear to be moving, not relative to us anyway. So how fast are we moving? And what direction are we moving in? If the universe is expanding and we're inside the universe, we must be moving in a direction, and we must be moving at a set speed. If we were moving in a set direction at set speed, then surely we would realize we were moving in that direction and that speed. The universe is also expanding at an accelerated rate. So if we're accelerating, we would notice a change in velocity. We would know what direction we're moving in, we would know what direction we're accelerating in, and we would probably know how fast we're moving. Yet, we know none of these. Let's just simplify the scenario a little bit, or oversimplify it a little bit. Let's say we have a bee. A bee can fly around the room. A bee knows if it's going forwards, a bee knows if it's going backwards. A bee can fly around a car. If the car is moving, And the bee can happily fly around the car, despite the car moving at a very fast rate, faster than the speed that the bee could possibly travel. Yet if the bee flew out the window, then as soon as the bee flew out the window, the bee would shoot off in the opposite direction, because the bee would no longer be moving with the car. The bee would know the car was moving because the bee would be left behind. So why is the same not true of our Earth? We know that our Earth is moving. We know that our universe is expanding. So if our Earth is moving in one direction, and our solar system and galaxy and universe are all moving in one direction, then if we have a spaceship which left our Earth, wouldn't that spaceship fly off in the opposite direction? That's just something to think about. Here's a couple other ideas that's worth considering. What about our sun? If we were moving, would we not expect objects like stars, which are effectively giant balls of gas, to have a tail, or to be shaped, or they wouldn't be shaped perfectly spherical, they would be shaped with a point on the end as they're moving fast through space. If they're just big balls of gas shooting through space, then why are they perfectly round and have no tail? If our sun was shooting through space, then why does our solar system orbit the sun in a perfect circle or symmetrically? If the sun was moving, then surely as the Earth moved in front of the sun, as the sun moved towards it, it would be closer. And as the sun moved behind the sun, as the sun was moving away, the sun would be further away. So here's our Earth rotating around the sun in a reasonably perfect circle, in a reasonably perfect spherical sun. But if the sun was moving, we'd expect the sun to have a tail, and we would also expect that as the sun was moving in this direction, if the Earth passed it, it would be closer, and as the Earth moved behind it, it would be further away, and it wouldn't be a perfect spherical orbit. Right? Well, maybe. I don't know. You could argue that there's inertia. You could argue that we may not know that because we're not changing velocity. So, what I'm just trying to get you to do here is just keep an open mind and think of these possible scenarios. I'm not saying that one is right and one is wrong, and I don't want to get into a big argument about it at the moment. All I want to do is to get you to question current theory. So, isn't it unusual that if we're moving through an accelerating universe, yet we do not have any idea what direction we're moving in or what speed we're moving in? In fact, we don't even appear to be moving. So, anyway, I don't want to argue this point, and I probably shouldn't have brought it up to begin with, but the point I want to raise is that if mass was shooting through space, then we would expect to know the direction and the speed that we were moving in. So perhaps we're not moving through space. So if we're not moving through space, then where did space come from? If space is a vacuum and we're not moving into space, then we must be moving with space. So if we are not moving through space, then we must be moving with space. So here's the scenario of the car moving along the road and our bee inside the car. Now if the bee is sitting in the car, it is moving at a very fast speed, but it doesn't know what speed it's moving. So we must be the same on Earth, and our solar system and our galaxy must be moving with space. So if space is a vacuum and we're moving with space, where did space come from? Well, space must be the vacuum created between particles as they separate from each other, correct? Well, if the universe is expanding, and it's not expanding into space, then it must be created out of the space between mass. So as the universe expands, so too is the expanding vacuum between the particles of mass. Right? Well, if space is the gaps between mass as the universe expands, then as the universe expands, the gaps between the mass must increase and a vacuum must grow. If a vacuum has been created and is expanding, as the vacuum expands, we would expect the force of the vacuum to increase. Therefore, if space was the gap between mass and the universe, we would expect space to have a strong negative pressure. If the universe was initially a single mass and there was no vacuum, then the force of all the space in the universe would be enormous. Space would have a strong negative force. But space doesn't have a strong negative force. So this idea must be wrong also. Here we have a balloon. If the balloon is tight and we expand the balloon, we create a vacuum. The bigger we expand the balloon, the bigger the vacuum is, and the greater the force inside the vacuum. However, if this is our universe and our universe is expanding, then why isn't the force inside our vacuum increasing? Well, let's go over this again. If space is a vacuum, then as the universe expands, it must be moving into space. Therefore, we would expect to know that we're moving. However, we're not. So this scenario cannot be correct. However, if the space in our universe is a vacuum between the particles of mass, as the mass moves away, then we would expect that the force of space to have a strong negative pressure, except it doesn't. So this scenario must be incorrect as well. So if space is a vacuum and we're not moving through it, and it's not expanding with us, then where did space come from? Well, my answer to this is that space isn't a vacuum. We can think of space as a medium of particles. What is space and how does it work? Well, let's go back to the basics. Let's look at the ring model. The ring model states that the universe is a giant expanding mass, just like a expanding mass of a cloud of gas. So here we have our cloud of gas, or our universe. It's made up of particles of mass. As the cloud of gas, or the universe, redistributes its mass due to a pressure gradient outwards, the particles are evenly distributed throughout that mass. So as a cloud of gas expands, the particles move depending on their pressure gradient and redistribute evenly throughout the volume available. Throughout that process, no empty vacuum is created inside that cloud, because if there is an empty vacuum, then there's a pressure gradient and particles will move into that pressure gradient and redistribute so that the cloud has an even pressure gradient and an even distribution of particles. Alright, so did that make sense? Let's try and explain it a little bit more clearly. So what happens when we have a gas that expands into a vacuum? A gas inside a scuba tank is highly pressurized. It is a dense mass in a small volume under a high pressure. All the particles are evenly distributed throughout the tank. There is no empty vacuum inside the tank. So here is our scuba tank, and here is our particles of gas. All the particles are evenly distributed throughout the tank, and the pressure of the particles is high compared to the surrounding pressure outside or the normal atmosphere. When we open our tank, the particles redistribute due to the pressure gradient and are evenly distributed throughout the surrounding volume available. Therefore, the same amount of mass of particles redistributes itself in a larger volume under a lower pressure. Therefore, no empty vacuum is left in any of the area available. It is all evenly distributed with particles, and there is no empty vacuum and no pressure gradient. So, evenly distributed particles, no vacuum, no negative pressure. That's gas. The particles expand outwards from the high pressure gradient into the low pressure gradient. They redistribute evenly through the available volume. The mass stays constant as the density decreases and the volume expands. The pressure reaches a new equilibrium, and the same mass of particles occupy a larger volume. But no vacuum is created. They are still evenly distributed particles, creating a mass or cloud. So what does this have to do with our universe? Well, if we look at the ring model, according to the ring model, there is no empty vacuum in our universe. The mass of the universe is evenly distributed due to the balance of forces between gravity and the pressure gradient. Therefore, according to the ring model, there is no empty space in our universe. So if there's no empty space in our universe, then space cannot be a vacuum. Space must therefore be an extremely sparse medium of evenly distributed particles, just like a cloud of gas from a scuba tank, and just like the evenly distributed particles or molecules of air in our atmosphere. Our atmosphere is not an empty vacuum. Our atmosphere is an evenly distributed distribution of particles, and so is space. So this is our universe, or our scuba tank. We have a small, highly pressurized volume of particles. If the pressure outside is stronger than the force of gravity, then these particles expand outwards and our universe expands. The particles redistribute evenly throughout the available volume as the universe expands, just like a cloud of expanding gas, and no empty vacuum is created. Therefore, there's no empty vacuum inside our universe, and our universe does not contain an empty vacuum. Therefore, space is not an empty vacuum. Therefore, space must be an evenly distributed mass of particles. And in fact, our entire universe is space. So therefore, our universe is in fact an expanding gas of space. Does this make sense? I hope so. Hope you're still with me. Anyway, what I'm trying to say is that space is not a vacuum. Space is evenly distributed particles. That's why space is not a vacuum. That's why space does not have a negative pressure. So, if we imagine that the air in a scuba diver's tank expanding, then we know that the mass of the particles in the air is constant, but the air expands as the volume increases and the pressure gradient decreases. However, as the air expands, the particles always remain evenly distributed. A vacuum or an area of empty space is never created, and if it is created, the particles of air would redistribute and fill that empty space, destroying any vacuums created inside that mass. The same is true of our universe. Therefore, there is no empty vacuum in an expanding gas, and there is also no true vacuum inside our universe. Any true vacuum with a negative pressure would quickly pull in particles of space, and the space or the particles in space would be evenly redistributed throughout our universe. Alright? So that's the theory. Many of you might disagree with me on this. So let's look at all the facts, let's look at all the phenomena, let's see how they correlate to space being a vacuum, and let's see how they correlate to space being a medium of particles. Anyway, this is the take-home message. Space is not a vacuum. Space is a medium of particles. Okay, so if space is not a vacuum, then what is space and how does it work? Well, I'm saying that space is a medium of particles. How does this relate to our previous two examples? Well, if space is a vacuum and we're moving into space, then we would expect to be moving through space. We don't appear to be, so that can't be true. If space is the gap between mass, as the mass of the universe expands, then the vacuum of space would be expected to have a negative pressure. This is not the case either. So what are we saying? We're saying that space itself is a medium of particles, that the universe itself is made up of space, or is space, and so the universe is an expanding mass of particles in the form of space. How does this relate to what we observe in the universe and the previous two examples? Well, if our universe is a giant expanding mass of space, or a giant expanding mass of particles, then these particles, where's my mouse, will move outwards together, but as the mass suspended in the universe, like our solar system or galaxy or Earth, will be moving with space as all the particles of space move outwards together. So here we have a particle of space, this particle, this particle, this particle, and this particle all move with it as it expands outwards. Therefore, objects of mass are motionless or suspended in space as the space itself moves or expands. Just like a boat floating in water doesn't move through the water moves and the boat is suspended in the water. That explains how we do not appear to be moving. What about the pressure gradient? Would there be a negative pressure of space? Well, no. As we imagine a mass of particles expanding, we know that the pressure never becomes negative. A vacuum is never created. The particles redistribute into a lower pressure gradient, and the pressure gradient of that mass decreases towards zero. So space would not be expected to have a negative pressure. Space would be expected to have a pressure which, as it expanded, as the volume increased, would get closer and closer to zero. So here we have our universe. Here we have the mass in our universe, which is the space, and the surrounding objects of mass suspended in space, and they all move together so that the mass of space appears motionless to the surrounding mass, and the mass of the universe, mass of the galaxies, all appear motionless relative to space as they're floating in space. This is the same as our scenario with the car and the bee flying around the car. So the car is moving, we know the car is moving, yet the bee appears motionless, suspended in the car, even though the bee is moving with the car. So this explains why we do not appear to be moving through space. This also explains why there is no pressure or negative pressure in space, and this is because space is a medium of evenly distributed particles. As the universe expands, the pressure of space moves closer to zero, and as the universe expands, we move with the space, not through it. So we can now think of space not as a vacuum, but instead as a medium of subatomic particles which contain mass, just like the medium of particles in our atmosphere, and just like the medium of particles in an expanding gas. In fact, this concept makes up a large proportion of my unified theory, and explains almost all phenomena that we observe in the universe today. I'm going to go on to explain most of these phenomena shortly, but first let's look at why space could in fact be a medium of particles. Let's compare space as a vacuum to space as a medium. So, back to basics. Let's look at the facts and observe phenomena of space and compare them to current theory and then to my theory. Current theory. Current theory is that space is a vacuum. My theory is that space is a medium of subatomic particles. Space is a medium of particles. So, this gets a little bit difficult for many physicists. Already have an extremely in-depth and complex explanation for many of the current observed phenomena and theories, just like why space is in fact a vacuum. But for a moment, can you please try and keep an open mind? Remember that all these phenomena could be explained by multiple different unrelated and sometimes extremely complicated theories, or they could be explained by one simple, extremely simple concept that space is a medium of particles. Okay, so let's come back to that soon. Let's look at the properties of a true vacuum and compare them to space. We believe that space is a vacuum because it has almost no atoms. Only one atom of mass for every approximately cubic meter of space. So we assume that the remaining volume is empty vacuum. But we also know that there are subatomic particles of mass much smaller than an atom. So it is still feasible that space contains mass, just not in the form of atoms, but in the form of subatomic particles. It's like saying that our atmosphere is a vacuum because there is no solid inside our atmosphere, but our atmosphere is gas, a distribution of particles much smaller than, or much less dense than the medium of a solid. Our atmosphere is a mass of gas. Our atmosphere is a mass of gas molecules. Space is a mass of subatomic particles. So, space versus a true vacuum. A true vacuum is empty, therefore a true vacuum cannot move or expand as it has nothing to move in. We would then expect that if there was nothing to move in space, that the temperature of space would be absolute zero, or negative 273 degrees Celsius. However, the temperature of space is 3 degrees warmer than absolute zero, suggesting that there are moving particles or energy in space. In fact, space is known to have a background energy. It has been theorized that this is the leftover radiation from the Big Bang theory. However, we could also argue that space contains moving particles, creating a background energy instead. Therefore, space has energy, space has a temperature, space must therefore have movement or something that creates that energy, like moving particles, and cannot be entirely empty. We also know that the universe and space itself are expanding. Again, how is it possible for a vacuum or nothing to move or expand? There has to be something in order for the movement or expansion to occur. Nothing cannot just become more nothing, because it is already nothing. It has to move into a place that was occupied by something, or something that has to move away from where it was previously occupied. Therefore, the only way a vacuum can move is if it is displaced by mass or displaces mass. A vacuum cannot expand into a vacuum or move through a vacuum. A vacuum versus a medium. So, space has a temperature of negative 270 degrees. Absolute zero is negative 273 degrees, suggesting that there is something creating a temperature in space. That extra 3 degrees could be from background radiation, or space could contain moving particles with kinetic energy and thermal energy. Space has a background energy. This is thought to be leftover radiation from the Big Bang, but it could also be because space is a medium of moving particles with their own physical energy. What about dark matter? Well, we know that the current observed mass of the universe is not enough to account for the gravitational effects that we observe and the rotation of many solar systems and galaxies. Therefore, approximately 20% of the mass of the universe has still been undiscovered. This includes mass inside our own galaxy. We can see millions of galaxies away. In fact, we can see 14 billion light years away. We can see in depth objects long distances away, yet we cannot see this undiscovered mass in our own galaxy. So what are the properties of dark matter? Well, we know that dark matter contains mass, and this mass has a gravitational force and therefore exerts gravitational effects on other mass. It affects radiation, but it does not emit or absorb light or electromagnetic radiation, and therefore we can't see it and we can't detect it. And this mass also accounts for up to 26.8% of the mass of the entire universe. And this dark matter also exists in our own galaxy. So, could space be dark matter? If space was made up of subatomic particles, then space itself would contain mass. It would have a gravitational effect on space, and space would have a gravitational effect on other masses. Space does not emit or absorb light, and space does not emit or absorb electromagnetic radiation. Space exists inside our own galaxy. In fact, space makes up probably about 99% of the volume of the entire universe. Therefore, if space was made up of particles, then it would have all the known properties of dark matter. Therefore, I believe space is in fact dark matter, because space is a medium of particles that contain mass and exerts a gravitational effect which exists inside our own galaxy. Therefore, dark matter has all the properties of space, and space has all the properties of dark matter. Theoretically, then, if we believe that space is dark matter, we can then calculate the volume of space and the unaccounted mass of the universe, and we can work out exactly what the mass of space is. So, space versus a true vacuum. If we created a true vacuum, say with a suction cup, it would have a strong negative pressure. For example, this plunger, which is approximately 100 mils, could hold up approximately 10 kgs off the ground. A small vacuum has a greater force than the force of gravity, just like this small vacuum here can oppose the force of gravity of this melon. Imagine a vacuum larger than Earth, or even larger than our solar system. Imagine a vacuum that contained all the space in the universe. This force must be enormous, much stronger than the force of gravity. If a glass of water or a spaceship or any other object left our atmosphere and went into space, then the enormous negative pressure of the space would pull that object apart. A vacuum surrounding our entire universe would be a perfect explanation for the expansion of the universe, as the force of the vacuum would be greater than the weak force of gravity. Alright, space versus vacuum. What about waves? A wave is a transmission of energy through a medium. Therefore, a true wave should not be able to pass through a true vacuum. Electromagnetic waves travel through space. We may not believe that light is a wave, but we know that radio waves are waves, and we know that most other electromagnetic waves are waves. In fact, we call these electromagnetic waves waves for a reason, because we believe they are waves. So how could radio waves, satellite TV, internet, radiation, heat waves, light waves, all be able to travel through space if space is a true vacuum, and the definition of a wave is a movement of energy through a medium? Now, I know that there are complex explanations to explain all these phenomena and facts, and that a wave shouldn't, but the simple basic principle is that a true wave, should not be able to travel through a true vacuum, regardless of whether it is a sound wave, an electromagnetic wave, or any other type of wave. And yes, we could come up with difficult, complex theories of why light travels through space, why other waves travel through space, but the simple fact is that it would make much more sense for a wave to be traveling through a medium than it would for a wave to be traveling through a vacuum. So either the electromagnetic waves are not waves, which we believe they are, or space is not a vacuum, which we believe it is. I believe space is not a vacuum. So, is light a wave? Well, we can argue. Is radiation a wave? Well, possibly. Heat? That also behaves like a wave. Radio waves, they behave like waves. Electromagnetic waves, they're even called waves. So, all these waves travel through space. So, either these are not waves because they travel through a vacuum, or, alternatively, light, radiation, heat, radio waves, and all other electromagnetic waves are in fact waves, and space is not a vacuum because they are a medium for these waves. Alright, so, moving on. There's a few examples of why I believe that space is a medium, and that's a few phenomena of why it would be more likely for space to behave the way it does because it is a medium and not a vacuum. What about moving with space and not through space? So, we know that the Earth, solar system, and galaxy are all moving. In fact, we know that the universe is expanding. So everything inside the universe must therefore be moving unless it's in the centre of the universe. Correct? Well, we don't know what direction we're moving in. If a person jumped out of a moving boat or a bee flew out of a moving car, then we would shoot off as we continue to move. And I've already covered this side, so we'll just go over it again. If a spaceship left our atmosphere, then we would expect it to shoot off in the opposite direction to the way the wave was moving, right? This could be explained if we imagine that objects were not moving through space, but instead suspended in moving space. So, for example, if a boat was moving through water, then an object would be left behind as it jumped off the boat. But if the boat was floating down a moving river and the water was moving, then the object would remain motionless relative to the boat. Right? So here we have a boat, and this little girl has jumped off the boat. The boat is speeding through the water, so the boat moves away from the girl. But if the boat is floating in the water, then the boat is still moving, but it is motionless relative to the water. So when the girl jumps out of the boat, she is motionless relative to the boat because she is also moving in the same water. This is the same for objects orbiting in space. Alright, the orbiting of objects in space is also better explained if space is a medium. So, currently we believe that objects in space orbit each other because they are travelling at the exact correct path, distance and velocity that the orbiting object got caught by the gravitational effect of that object as it was passing. In other words, it is an absolute miracle that any object rotating or orbiting another object was moving at the exact right speed, the exact right distance, and had the exact right mass to be caught in its orbit, just like the moon orbiting the Earth and the Earth orbiting the Sun. So here we have the Earth, it just happened to be shooting through space, and all of a sudden it gets caught by the gravitational effects of the Sun and begins to orbit the Earth. That's current theory. But if the size of the two objects was any different, or the distance between the two objects, or the angle that the objects were travelling, or the velocity, or the directions, or anything in this equation was slightly different, then the two objects would not orbit each other, and the objects would either shoot off into space or crash into each other. Under that logic, it's an absolute miracle that any object in the universe is orbiting any other object. But in fact, every object in the universe is orbiting another object. So how can this absolute freak occurrence, miracle of nature, happen so consistently every time? Well, under this logic, it's amazing that any other objects can orbit in the universe. However, every object in the universe is orbiting something. How is it possible for such a miraculous event to happen so frequently or every single time? In fact, if an astronaut went far into space, he would automatically orbit the Earth. But where did his perfect projection come from? Where is his lateral movement? What caused him to orbit the Earth? It just appeared to happen for no particular reason. And as soon as he comes out of the orbit, then he falls directly to the ground. It doesn't make any sense. This theory doesn't quite add up. Why does gravity behave differently on Earth than it does in space? Well, according to my theory, space is a medium of particles which is drawn together by gravity. For example, let's imagine a bathtub full of water and some balls floating in the bath. If we pull the plug, then the water in the bath orbits the drain as the water is pulled down the drain due to gravity. The balls floating in the water will also orbit the drain as they wait for the water to go down. This is because the balls are floating in the water and the water is circling the drain. But what happens if the bathtub is empty? If we put balls into a bathtub which was empty, then the balls would fall directly towards the plug, taking the shortest direction due to the force of gravity. The balls would not orbit the plug. This is the same for objects orbiting each other in space. If space was a true vacuum, then we would expect objects in space to be pulled directly towards each other. We wouldn't expect objects in space to orbit each other. They would take the path of the shortest distance due to the force of gravity, which is directly to that object. However, objects in space do orbit each other, and this is because I believe that space is a medium of particles in which other objects like Earth and masses like the Sun are floating. If we imagine that objects are suspended in a medium of space, and that space is being drawn in by gravity, then the second object would orbit the first object as it waits for the space between the two objects to be drawn in by gravity. Does that make sense? I hope so. Hence, if space was a medium, it would better explain why objects in space orbit each other, just like objects floating in the bathtub of water. So here we have our empty bath of water, and if we drop these balls into the empty bath of water, they fall directly to the center of the bath due to the shortest course due to the force of gravity taking the shortest course. However, if we have a full bathtub of water and we drop these balls in, then the water will circle the drain as gravity pulls the water in, and as the balls float motionless in the water, they will also orbit the drain as they wait for the water to go down the drain. So gravity in the bath. So when the bath is empty, like a vacuum, the balls fall directly towards the centre due to gravity. So if space was a vacuum, we would expect objects in space to fall directly towards other objects due to the force of gravity. But when the bathtub is full of water, this acts like a medium and the balls circle the bath like an object orbiting in space. So if space is a medium of particles, then as gravitational forces like the Sun and the Earth pull in space, the objects floating in that space will then begin to orbit those gravitational forces. If we assume that space is a medium of particles, then this accurately describes why all objects in space orbit each other. This is opposed to the current theory that it was put down to, quote, pure luck. Every object in space was moving at the exact right angle, velocity, and distance to be caught by the gravitational effect of every other object in space that it is orbiting. So, galaxies. If space is a medium of particles affected by gravity, then this could also explain the formation of the universe as we observe it today. So if space is a mass, then the expansion of the universe may have been in the form of a rapidly expanding mass, like rapidly expanding space. If the early universe was made up entirely of particles of space, then this could explain the formation of objects in the universe today, like objects of mass and galaxies. If individual particles of space accumulated together due to the force of gravity between those particles over time, then as those particles began to grow in mass, their gravitational force would increase and they would pull in more space. They would then pull in more particles and they would accumulate in mass. Therefore, as more particles combine due to the gravitational force of the mass, it pulls in more space and more mass faster. Over the course of the last 14 billion years, particles of space would have accumulated due to the force of gravity to create the universe in the form that it is in today. Galaxies, planets, individual masses inside the universe are the accumulation of space or particles in space due to gravity. Therefore, we can think of galaxies as dense balls of precipitated space or masses pulling in space and continually growing and continually contracting due to the force of gravity. In fact, large objects like the Earth, Sun, black holes will all be continually growing as we speak and throughout time as they continue to draw in particles of space. An expanding universe and a contracting universe. So, if the formation of galaxies is due to the accumulation of particles of space over time due to gravity, then galaxies will continue to contract and continue to grow as they draw in more particles of space due to gravity. Therefore, the universe and space may be expanding on a universal scale, so the universe itself is expanding, but on a local scale, objects of mass are still growing and condensing due to gravity. And that comes back to what I was saying before, that everything in the universe is individually proportionate to the balance between the force of gravity and the force of the surrounding pressure gradient, or negative space. Therefore, the universe can be expanding on a universal scale because this force of the negative space is stronger than the force of gravity, but on a local scale, individual particles may continue to accumulate and grow due to gravity. So, it is currently believed that space is a true vacuum. However, there is no conclusive proof that it is, and nothing has excluded the possibility that it cannot be a medium of particles. There are also multiple phenomena that suggest that space is in fact a medium of particles. Space has no negative pressure. Space transmits waves like electromagnetic waves, light waves, heat waves, radio waves. It also has a temperature and a background energy, which would be better explained if space was a medium of moving particles. Space can move, and the universe can expand. Therefore, space must contain something in order to expand. Space can be affected by gravity, and I'll just talk about this more shortly. If space is a medium of particles, then this better explains why objects in space orbit each other, and this can also explain how the universe was formed today due to the creation of galaxies. What else have I missed? Space also explains the existence of dark matter, and I'll talk about shortly how space explains the existence of dark energy. So in summary, I believe that space is not a medium. I believe that space is not a vacuum. I believe space is a medium of particles. This explains the creation and expansion of the universe through the ring model. So if we come back to the creation of the universe, if we believe that space is a medium of particles, then we can understand that outside our universe is a true vacuum of negative space. And this explains how our universe was created and why it is expanding into a negative vacuum, because the space inside our universe is not a true vacuum. This also explains why the space inside our universe has no negative pressure, despite the universe continuing to expand and the vacuum or the space inside our universe increasing in size. This explains the existence of dark matter, because dark matter has not been discovered yet. It has been discovered that almost all objects in space, including our solar system and galaxy, are orbiting in a smaller radius than we would expect with a calculated observable mass. Therefore, a large amount of the mass of our universe has not been discovered. It was then postulated that a dark matter exists outside of our detection. This dark matter. Dark matter has never been discovered, but we know it is in our own galaxy. So let's look at the facts. We know that this matter contains mass, which exerts gravitational effects. We know that dark matter is in our own galaxy and every other galaxy. We know this matter does not absorb or emit light or electromagnetic radiation. Space fulfills all of these requirements. Therefore, space contains mass, which is affected and has effects on gravitational forces. Space is abundant throughout our galaxy and all the rest of our universe, and space does not emit or absorb light. Therefore, space fulfills all the criteria of dark matter, and space is the mysterious, undiscovered dark matter. Space also explains dark energy. So, dark energy. Dark energy is a concept created to explain the expansion of the universe. Dark energy has also never been discovered. However, if the creation and acceleration of the expanding universe is caused by negative space surrounding our universe, then we have a perfectly sound explanation for the existence of dark energy. Therefore, we no longer need a concept of dark energy, an entity which probably does not exist. We have a reason for the universe to be expanding, and we have a reason for the universe to be expanding at an accelerated rate. And that reason is the negative space or surrounding vacuum of the universe. Negative space is responsible for the expansion and acceleration of our universe, and therefore negative space is the dark matter that we are looking for, or sorry, the dark energy that we are looking for. So in summary, if space is a medium of particles, then this explains the creation of the universe, it explains the characteristics of space, explains dark energy, it explains dark matter, and it explains the formation of galaxies, and it explains why objects in space orbit each other so consistently and so reliably, and it's not just put down to chaos and dumb luck. So, a unified theory. Over the last 3 videos we've discussed a simple concept. This is a concept of space being a medium of particles, and that medium of particles responding to the pressure gradient of the surrounding vacuum versus the force of gravity. The ring model describes the shape and movement and distribution of the universe over time. Using the ring model, we can go on to understand our universe is a large expanding mass in the form of space. We can then go on to explain what it is like prior to the creation of our universe. We can also explain the creation of our universe and why it is expanding due to the force of negative space. We can also understand other observable phenomena like the formation of galaxies, why objects in space orbit each other, and the existence of dark matter and dark energy. So, my current theory versus current belief. Well, there are currently multiple theories that explain many phenomena that we observe in our universe. Theories like dark energy, theories like dark matter, which are partial theories. They explain single phenomena. They don't have explanations, they haven't been discovered, and they don't fit in with the big picture. Some of these theories are complex and partial and only explain parts of what we observe. The Big Bang Theory partially explains the creation of the universe, but it doesn't explain how it was created, and it doesn't fit with current physics. NASA theorizes that the universe is flat, but this doesn't make sense with what we observe in our universe as regular everyday phenomenon. Einstein's theory of relativity complexly begins to explain the movements and characteristics of light and time, but again we're stuck with why light behaves the way it does, and why light travels at a constant speed, and why time is affected the way it is by relative movement or gravity or any other unrelated variable like light. So, all these theories leave many unanswered questions and currently do not appear to be intimately related to each other. Alternatively, there is my theory, which is simple. It's a single theory and it explains all observable phenomena. I then ask you to keep an open mind. I know that this is far from conventional thinking. I know that this does not fit with current theory. I know that current theory has been widely proven, but what I'm saying to you is that this also fits with current observable phenomena. It doesn't break any exceptions to the rule. It does fit with the current facts, and it does simply and methodically explain everything that we observe in the universe today. So just because you believe something to be true, it is more logical to say that one simple theory which explains all phenomena is more likely to be accurate compared to multiple different complex theories which only partially explain some phenomena. Right? So far so good. Alright, so sorry this presentation hasn't been as well prepared. It's been a bit of a roller show. I hope you're still following me. I hope I haven't made anyone angry. I hope you still agree with me, and if you don't, please continue to watch, because my next presentation I will explain everything much clearer, much more concisely. So, let's look at our checklist. We have a single concept. The concept is that space is a medium, that space is affected by gravity, and that space is also affected by the pressure gradient of negative space. It's simple. I haven't used anything out of already proven science. It's all basic textbook secondary school stuff. It's the balance of forces, it's mass, it's gravity, it's the pressure gradient of a vacuum. I haven't used any complicated concepts. I haven't used dark energy. I haven't used dark matter. I've helped to explain the observable phenomenon. I haven't used string theory. I haven't used alternative dimensions. I haven't used any quantum physics or anything else that is complicated. It is just basic, simple physics explaining basic, simple phenomena that we observe every day. Now, has my unified theory explained anything? Well, it's partially explained the universe. It's partially explained some space, and I'll go on to that more. It's partially explained dark energy and dark matter.